Hey, first grade, it's Miss Beck. I know you can't see me, but I really wanted you to be able to focus in on this page of your week 2, day 5 packet. This is a very important concept, and it can be very challenging for our first graders. We have taught this probably 2 or 3 times this year, and we've taught it, and then we reviewed it, and it can still be quite a challenge for them. So we're just going to jump right into it. So this is a big part of your student understanding the equal sign. So whenever you have an equal sign, you need to know what that means. So if you have an equal sign and you have stuff on both sides, because you're not just going to have a random equal sign with nothing there unless, you're filling in the math problem. So when you see an equal sign, that means that both things are either both problems, both numbers, are going to be the same. So if I added 3 plus 5 and then 5 plus 3, I should get the same answer. So one strategy that I showed my class whenever we were doing this is that when you have something like this, and you may not know, they may not have that quick sense of math and addition or subtraction, and just be able to know that 5 plus 3 is 8. So just give them some time and have them write the answer underneath it, because there's nowhere for it to really go because the equal sign has something on both sides. So if they know, and I always tell them, just bring that equal sign down and put it down here. And if these two numbers are the same, then this problem is going to be true. If they're not the same, then this problem is going to be false. And if you notice, I put a little check over here for true, and I put a little X over here for false. Now, I know in your packet, I think it's also going to have you put maybe an equals for empty boxes like this one if it's true, or an X if it's not, and that's fine as well. So one thing that I really want to mention really quick is that sometimes your child is not, this is called commutative property up here. Some people call it a switcheroo or flip around, but it's just where they have this first problem and then they just flip-flop the way that it looks. Not every single problem that you have is going to be like that. Sometimes you might have a problem where the numbers over here are different. So let's say that you have 2 plus 6 over here instead of 3 plus 5. Well, if I'm looking at that and I'm not taking my time to actually add the answer up and know that both sides equals 8, then I'm going to automatically think that it's false because the numbers are not the same. So we really have to make sure that when your child is looking at this, or students, whenever you are looking at this, that you are taking your time and you are adding those up, because just because the numbers are different doesn't mean that it's false or unequal. So 3 plus 5 is equal to 8, and if you add 2 plus 6, that also equals 8. So this equation would be true. Now, on your paper, I kind of sectioned this off into the different things that your child is going to see. You're going to have different areas. So you're going to have an area where you're going to have to circle these equations if they're true. Now, this one right here, you don't have any math to do. It's just 2 numbers. If you have 4 cupcakes and your neighbor has 6 cupcakes, who has the most? Now, hopefully, they're going to be like, my neighbor does, because I want 6 cupcakes. That's not fair. And it's so funny because I always add a food equation to this, or candy, because I'm like, well, if Andrew has 6 pieces of candy and Sophia only has 4, who has the most? And then they kind of are like, oh, that's not fair. So you can always do that with your child. If they're really not understanding, you can ask them a question. And sometimes it helps if you put their name into the equation as well. So if Miss Craig has 4 pieces of candy and Miss Beck has 6, who has the most? Miss Beck does. So this is not true. 4 cannot equal 6. We do not have the same amount. Over here, you have a number, and then you have an equation. So the same thing that you did up here, I will just have your child add these numbers over here and put it underneath it, and then they can kind of see that 7 is equal to 7, and they can circle it and say that that's true. On this side, is kind of what we did up here where the numbers are completely different. So it might be their first instinct to just say, oh, those are not true because they're not the same numbers. Well, we're not looking at the numbers per se that are just here. We're looking at, if you add these together, what are they going to equal on both sides of the equal sign? So 5 plus 3 is 8. We figured that out at the top. And then 7 plus 2 is 9. So can 8 be the same as 9? And I'll say the same thing that I said over here. If your child can get to this step where they know the numbers and they just can't process that, you can always do what we did over here and say, well, if Javion has 9 pieces of candy and Remini only has 8 pieces of candy, who's going to have the most? And or are they the same? You can even pose that question. Do we have the same amount, or do they have the same amount of candy? And you're going to be like, no. So you're going to cross that out because that is not true. Now, down here at the bottom is when things look a little bit funny. So one thing that I always do, because these boxes can be really confusing, is I will have the children put a line between the dots so they know that, like, this is one set of dots, this is another set of dots, this is one set of dots, this is another set of dots, because sometimes they'll just go through and they'll count all of them and then write it down. And that's not what they want you to do. They really want you to bring those dots down to certain areas. So count them over here. 1, 2, 3. That's 3 dots. 1, 2, 3, 4. That's 4 dots. So right now you have 3 plus 4. And then you have this blank box that I mentioned earlier. So this blank box is going to be where your child either puts an X or puts an equal. Now, if they put an X, that means that these two are not equal. If they put the equal sign, that means that they are. Now, over here, you have 5 dots and you have 2 dots. So the next step would be the same thing that I did up here, because some children can't just look at these numbers and know them so fast. So I always tell them, even if you can, just go ahead and write that answer underneath, because if you go back and let's say that we're in class or we're at school, and one thing that I will do is I'll say, explain to me how you found your answer. Well, they should be able to go, well, up here in this box, there were 3 dots. I had to bring that down. And then I added 3 plus 4, or I did the same thing over here. And then I added 3 plus 4, and that gave me 7. And then they're going to come over here and they're going to say, well, there's 5 dots here, 2 dots here. And that gave me 5 plus 2, and 5 plus 2 is 7. Now, if your child can't just do that like I just did, I mean, I've had a lot more experience, but if they can't, feel free and let them count the dots. That's why the dots are there. They're not just there for them to look at, they're there to help them. It's almost like if they had beans on their table or cereal on their table. And if you wanted to, you could even take a little piece of cereal and sit it on top of those dots if that helps your child to have something in their hands. And so they can count the dots and go 1, 2, 3, 4, 5, 6, 7, and then get their answer. So the last step is going to be looking at these 2 numbers. Is 7 the same thing as 7? Yes, it is. We only have 1 7. So 7 and 7 are equal, and 3 plus 4 is equal to 5 plus 2. Because if we add those together, they will both equal 7.